Welcome back to naming ionic compounds. This time we are going to take a look at polyatomic ions. Polyatomic ions, poly means many, and then atomic obviously atoms. So we're looking at atoms that are joined on the periodic table. Polyatomic ions are sometimes called oxyanions because they tend to have negative charge and they tend to contain oxygen. So the formal definition is two or more atoms or ions can combine to produce a new, larger, stable ion called a polyatomic ion. Because it is an ion, it is named according to the Ionic system, but the sad thing is you must memorize these. And the list of how many you memorize will depend on your textbook. But here's an example. So ammonium we have discussed before. It's the only positively charged polyatomic ion that will form bonds. It's commonly known to form bonds. And so this or a metal would mean an ionic compound. But notice that most of them have negative charge. And also notice that most of them end in ate, or several end in ite. If you see an ate or an ite, right away you should think of the polyatomic ions. A lot of times when students struggle with naming, it's because they haven't memorized these. And the best method to memorize these is to use a flashcard system where you put the chemical symbol on one side with the charge, and then you put the name on the back. There are many Quizlets online for this. I'm going to show you a mnemonic device for this in my next video, but they can be complicated. There are also several that end in IDE, which is annoying because it would be nice if they all ended in ate or ite, and then you know automatically that it's a polyatomic ion. But poisons like cyanide, peroxide, they tend to end in IDE, so it tends to be the polyatomic ions that are poisonous. But notice that they still, all of them have more than one type of atom. Peroxide only has two oxygens, but it has a 2 negative charge, whereas oxygen in air doesn't have a charge at all. And notice also that the ates, nitrate is a good example right here. You really only need to memorize the ates because the ite version will be identical. It'll have the same charge, but one less oxygen. Sulfate's another example. Sulfate has a -2 charge, 4 oxygens, but over here, sulfite has one less oxygen, but the same charge. Notice also that sometimes they write 2- and sometimes they write -2. It really depends on the textbook and your professor as far as how they prefer. It tends to be standardized now to do the number and then the negative, but organic chemists tend to do the negative and then the charge for some reason. And then also notice that some, like carbonate, with its -2 charge, will have a hydrogen in front. And as soon as it has a hydrogen has a plus charge. Now the -2 charge goes to a minus. And it's just called hydrogen carbonate. So they'll have the same name as it did over here, but now it'll be hydrogen carbonate. Phosphate is another example. Here's phosphate. Put a hydrogen in front. The charge drops to a -2. And now it's hydrogen phosphate. Another thing to notice is that, or to note, is that you can't change these little numbers. These little numbers are called subscripts, and you can't change them. You also can't change the charge. The charge that goes with it is the charge that makes nitrate nitrate, sulfate sulfate. You can't change the number of oxygen. Again, that's a subscript. If it weren't NO3-, it wouldn't be nitrate. So you cannot change these. You memorize them exactly as they are, and you can't change them when you write out the formulas. And again, in the next video, I will show you how to memorize at least half of these using a mnemonic device. But first I want to show you what they look like when they're drawn out. So the hydroxide ion is commonly found in Drano. It's usually sodium hydroxide or potassium hydroxide, and it is poisonous to us. So that's why Drano, they typically want you to wear goggles and gloves when you're using it. Also notice that it has a negative charge, and they typically put it in brackets in inorganic chemistry or beginning chemistry. And then it shows that it has a covalent bond, which is a line that just means it's sharing 2 electrons. We'll talk about this later. This is a Lewis structure. But I kind of wanted you to see what they look like drawn out, because when they're like this and you're just memorizing, students always wonder, what do they actually look like when they're floating around in solution? This is what they look like. It doesn't make as much sense. Like, what are these dots? These are valence electrons. We'll learn about these in a later chapter. But you can kind of see perchlorate is commonly used to make explosives, and it has 4 oxygens. One of the oxygens will have a charge. Hypochlorite, commonly used in bleach. This is my fancy drawing of bleach here. And it's usually with sodium because it can't just float around in solution with a negative charge. It has to have a positive charge to stabilize it. The sodium doesn't do anything. Sodium in any solution doesn't do anything. It's just stabilizing negative charge. But this is what the hypochlorite would look like. If you go back to the original list, you see perchlorate on here, the one that we learned for explosives. You'll notice that hypochlorite is just like this, but it's down to just 1 oxygen. And then nitrate, which is a really common one. And these are the same. The only difference is they're shifting the double bond around, and that happens with molecules naturally. Nitrate comes about from nitrogen fixation in plants, and it's typically found in high levels in surface water. So nitrates are also triggers for migraines, so foods that are high in nitrates and nitrites we try and avoid. And when you see a polyatomic bonded, once you've memorized it, again, it's much easier. But notice it's always with this metal compound or ammonium, the one exception to the ionics, where it's a nonmetal, but it's a polyatomic. And then when they have parentheses, when you see parentheses around polyatomics, it means there's more than one. So this one has no parentheses because there's only 1 sulfate. You look at this 4, and maybe it looks like there's more than one, but no, sulfate is just SO4. In the next video, we'll also look at how they came about balancing these, because just like the other ionic compounds, you have to balance the charge.